All right, everybody. So in this video, there is not going to be a lot of math, and I know that sounds strange, or maybe that's something you'd get excited to hear. I don't know. But I want to make a video that's a prelude to some of the concepts and some of the recent lessons in videos and in some of the future lessons in videos. Okay. So rate of change is something that came up before in earlier videos when we talked about the average rate of change. And we'll be talking about something new called an instantaneous rate of change. But before we got too deep into that, I wanted to talk about what is a rate of change. Okay. Um, so I'll use one function, one example in order to show you, and then I'll just have to ask that you use your imagination from there. Okay, but you can learn what a rate of change is if you don't already know by just one example. So suppose that I have, now this is a very common type of function, a very common equation that we'll see throughout the semester. Okay, so this is a revenue function. And what this function does, let's suppose, is that it will calculate the revenue from producing and selling X units of some product. Okay, so you tell me how many units of the product you produce and sell, and this will calculate an expected revenue from that. Okay, that's what it does. You tell me the production, and it calculates the revenue. Now, that's one thing. Maybe you just want to know what the revenue is at a certain level of production. Okay, that's one thing that somebody might want to know. And that's what this equation does. But there's something else. Like we might also need to know, and what I'm about to tell you is very important in the study of economics, at least for some topics that you study. And it's how changes in production can affect changes in revenue. So we might expect that, sure, you produce so many units, then you get such and such revenue. But if the production were to increase or decrease, how much of a corresponding increase or decrease would that cause in the revenue? Because they are linked together, right? The revenue is a function of the production. They depend on each other. So if the production were to change, if it were to go up or down, then we would expect the revenue to go up or down. And we might want to know how sensitive it is. We might want to know how much does the revenue change as a result of an increase or decrease or any change in production, okay? How does one of these variables change in response to the other one? All right, so that will be an important and a big question for us, a big topic throughout the semester. Is not just how do you calculate what something is, but how do you calculate how change in one thing causes change in something else, no matter what you're talking about. Here, it's revenue as a function of production. All right. Now, the way that we can answer this question and measure how changes in production influence changes in revenue is by either an average or instantaneous rate of change. Okay, that's what a rate of change does. It quantifies or measures the change existing between two variables. And here our variables are production X and revenue R. All right. Okay, now the average rate of change, we've talked about that a little bit. I've showed you how we could do calculations with the average rate of change in previous videos. And the instantaneous rate of change is going to be here soon. Okay, so now let me take an example. I'll show you how the average rate of change answers this question directly of how changes in production influence changes in revenue. I'll show you, okay? So let's do this example where we calculate the average rate of change for this revenue function, okay? R of x is 4x minus 0.001x squared from x is 900 units to x is 900.1 units. Now you might not like that I used, you might think, well, shouldn't that have to be a whole number? And we might say, well, maybe x is measures thousands of units, okay? And in that case, you could have a decimal like 0.1. But nonetheless, all right, we will calculate the average rate of change for this revenue function between these production levels. All right, now according to formulas I've given you already, this is what that average rate of change is. R of 900.1 minus R of 900 over 900.1 minus 900. Okay, doing my calculations, I get the revenue at 900.1 is, say in dollars, $2,790.22. And the revenue at a level of production of 900 is 2,790. Okay, now think about it. We're talking about a rate of change, an average rate of change. Do you see how this is change? I mean, if this is the level, if this is the revenue at this level of production, and this is the revenue at this level of production, then you subtract them. That's the change between one to the other, right? So what's the, if your initial revenue is $2,790 at a level of production of 900, and it increases to $2,790.22 at this level of production, then there is a change, an increase, okay? What is that increase? What is that change in revenue? Well, it's about 22 cents, all right? 0.219. Now this had some rounding in it already, so that's why this is not exactly 22, but all right, there it is. So that's the change in the revenue. This number up here will be the change in the revenue between the two corresponding levels of production that are given. And then when you subtract these, that's obviously the change in production, the increase in production. So yeah, that is a rate of change. We get a fraction that quantifies the change in two variables as they change together. Remember, we said a change in production, increase or decrease in production, will cause a corresponding increase or decrease in revenue. And that's how. An increase in production of 0.1 will cause an increase in revenue of 0.219. All right. Do you see this thing right here? Whoops. Let's see. Let's do that. Do you see like this thing right here? That's a rate of change. It answers that question that I posed to you back here. How do changes in production cause changes in revenue? This is how. A 0.1 change in production causes a 0.219 change in revenue. All right. Now, then that has units, then doesn't it? There are measurements that goes along with this. Like how were we measuring the revenue? Well, I said dollars, okay, when I explained how I was thinking about this. And then how do we measure production? Well, we say units. We say we produce so many units. So there's the units of measurement to go along with this are dollars per unit. Okay, now that gives you a way to think about this number. We can say, well, here's roughly what this means. At a production level of 900, each additional unit produced will yield about $2.19 of additional revenue. That's the number I get when I divide these out. So instead of saying 0.219 over 0.1, when I divide it, it's like it's 2.19 over 1, okay? So that's why I can say one additional unit of production will give me about $2.19 of additional revenue. It's kind of like, I always use the same example, but you could say in your car that you're traveling 120 miles per 2 hours, but that's a little bit awkward to say, even if it might be true, 120 miles per 2 hours. We'll normally just divide the 120 and the 2, and then we'll say 60, and say 60 miles per what? Per 1 hour. 120 over 2 is 60 over 1, so that's how we come up with that number. So yeah, that thing right there, that's a rate of change. It captures the corresponding changes between two variables that are already linked together. It tells you how they change together. It tells you how change in one is causing change in the other. It gives you the numbers for that, okay? Other common rates of change. Well, I mean, speed's a rate of change. Like up here when I was talking about your car, speed is a change in position and over some change in time. Your car can change its position 60 miles in total distance, and the change in time on a clock could be an hour, and that's a 60 miles per 1 hour. It's a speed, okay? So that's a real common rate of change that everybody experiences all the time. Now, so before we get to the next video it will be about the instantaneous rate of change. And I'm afraid the math might be a little more complicated at first for that. We'll find simpler ways to do things as we go along. But let's look at it like this. Here's the average rate of change that we've already learned about. Okay? This is how you calculate the instantaneous rate of change. All right, it involves a limit. And if I ignore the limit, it's still a fraction. And it turns out that if you ignore the limit, these are really the same. Okay? This is, if we were using a revenue function, this would be the change or the increase or decrease in revenue. And this down here would be the change or increase or decrease in production. Okay? So if you ignore the limit, there's really no difference between the average and the instantaneous rate of change. Okay? So if the limit makes it seem mysterious, just forget about that for a second, and I'll tell you that even though they look different, they are no different. Now the limit, though, does add some complexity to the math, though. But what the limit does is like it pushes B and A together, you might think, okay? As far as why it's called the instantaneous rate of change, well, this is calculus. Calculus was something developed out of physics, and physics was initially concerned with explaining motion, and this variable down there was time, okay? And if you were to push, think about what an instant in time is, a specific moment. If you were to push this, here's an interval of time, and if you push that to 0 like it says, then it becomes an instant. So that's why it's called the instantaneous rate of change. All right. Now I've told you, if you ignore the limit, these formulas are no different. F of B minus F of A over B minus A is no different than this, F of A plus H minus F of A over H. They look different, but they're not different, all right? Okay, now what the limit will do is push these, the B and A together, you might think. Now that's just a rough way of thinking about it, but it's still accurate. Now, as far as them being different, yeah, okay, they are different. This one has a limit and that one doesn't, so yes, they are different in that way, but they will be, the average and instantaneous rate of change will be approximately equal if this number B is really close to that number A. Okay? All right. Now, I'll show you how you can demonstrate that. In the next video, I'll do an example where I calculate something called the marginal revenue. Okay? And it's based on having a revenue function, like the one I used in my example just a minute ago. Okay? And remember how I said this part of the instantaneous rate of change is just like this part in the average? Well, in that case, this top thing right there, that will be the change in revenue. That is the effect from this part, all right, like that, which is the change in production that caused it, all right? All right, so that will be like one of the examples that I do. And you'll find that you can test out this claim I just told you. The average and the instantaneous rate of change will be approximately equal if B and A and the average are really close to each other. We'll look at it like this. I did this example with this average rate of change where I got 900 and 900.1. Those are close. And the answer I got for this was $2.19 per unit. On my next video, I'll do this example with the marginal revenue. And I will get $2.2 per unit. So yeah, the average and the instantaneous, though different than each other because of the limit, you'll find are approximately the same if B and A are close together.